Hello everybody! So welcome back to another exciting video with me, Daniel Bullen, for my YouTube channel, Learn Computing with Daniel Bullen. So this is what I'm calling all future tech wizards. So, are we ready to unlock another suite of secrets of the GCSE Computer Science practical paper for the AQA exam board? So join me, Daniel Bullen, on a journey through the depths of this paper as we unravel complex concepts, decode some pretty tricky questions, and arm you with the knowledge to ace those exams without the faff on analogies about recipes. So if you're fed up with analogies on recipes that have no relevance whatsoever, or where you can buy the best soy sauce, you've come to the right place. So whether you're seasoned at past papers, or just dipping your toes into the world of computer science for the very first time, this video is by golly your passport to the ultimate success. So hit that subscribe button, grab your virtual notebook, hit the like button and share this video far and wide, especially if you want your pals to succeed with you. So let's embark on this epic adventure together. So let's get right into this paper. I'm not going to show you all the front stuff because invigilators will go through that just before the exam. So, figure 1, question 1. So the pseudocode in figure 1 assigns 2 string values to 2 variables. Title and level, they are your 2 string variables. So we need to shade 1 lozenge that shows the length of the contents of the variable level in figure 1. So if you shade more than 1 lozenge, you're going to get a big fat 0. So we know it's going to be D. That's literally it. So show the variable level in figure 1. It's just going to be D. Okay. Now we need to shade 1 lozenge. That shows the result of concatenating the variable title with the variable level. So it's going to be D. It's not going to be A because there's a space. And in level, there is no space. And at the end of title, there is no, you don't see space there, which is why the answer's D. So you've got to be quite careful. C's wrong because there is space in the title string. Okay, let's press on. Shade 1 lozenge to show which of the following strings is a substring of the variable title in figure 1. So the lozenge we need to shade is C. The substring, that is a substring there. Okay? And then last but not least, Unicode character of title 0, which is C, is 99. Shade 1 lozenge to show the Unicode character of the character level 3. So 0 is C, 1 is O, 2 is M, 3 is P. So that is going to be, but that is just title. We want level. So the level is actually going to be 101, as in, and I'll be, so title level 3, if we go back up, 0, 1, 2, 3. So E is basically 101. Right, on to question number 2. So we should have 4 marks in the back for question 1 if you get those right. Question 2, we got 3 examples of code in figure 2, all equivalent to one another. So you got example 1, an if statement in pseudocode. Example 2 is an assembly language program. And example 3 are all binary digits. Woo! So this is one question as part of our quest to complete this paper. So we need to, boring one so far. Shade 1 lozenge to show the statement that's true about figure 2. So None of the examples is in a low-level language. That's not true because example 2 is in low-level. It's not going to be B, only one example, because there's going to be more. There's 2 examples. And only if all of the examples are in a low-level language, no, it's not, because example 1 is in a high-level language. You could mock this up in C#, C++, Python, etc., or Java, etc. So it's going to be C with 2 examples are in low-level language. So the answer is C. If you shake that lozenge, you're in for the mark. Bosh. Done. Okay, for this question, this requires us to explain why a developer who is good at both low and high-level language programming would normally use a high-level language when writing programs. That's because high-level languages have built-in functions. Especially Python, it will have a lot of built-in functions. And also, high-level languages will have more support for the developer. So they'll tell you where it's going wrong, a little bit about what's going wrong, and I know in some IDEs like REPL, you can use AI to actually debug the code for you. But we're not gonna cheat. There's cheating, you're gonna get disqualified. So don't cheat unless you want to get disqualified. Back to the question. So you could say it is easier to find mistakes in the code, and it is quicker to develop code in high-level languages. Absolutely true. These answers will get you 4 marks. There are more, so you could have the code is easier to maintain, it's easier to structure code in high-level languages, so there's loads more options you could have. But I would mention those 4, they will get you 4 marks. There was a question like this on another paper, exactly the same, so it's copy and paste the mark scheme. Copy and paste the mark scheme, bosh. Right, number 2, part 3. So we've got statement A and B refer to 2 different types of program translators. So type of translator can convert high-level language program into machine code. Source code is analyzed fully during the translation process. The result of the translation can be saved, so the translation process does not have to be repeated. Section B. This type of translator is used to convert code in example 2 to code in example 3. So, statement A is a compiler, and statement B is an assembler. Because assemblers will convert high-level language programs into machine code, whereas assembly language to machine code, that's going to be an assembler. Question 3. Recipes, blooming recipes. I know, I feel sorry for people who have to go through some certain computer science teachers who just bang on about analogies of recipes. In fact, there's so much recipes going on, and I'm surprised you haven't banged a few out in the oven. But hey, I'm not going to say too much because this is a family video and I don't want YouTube going, So, cake recipe uses 100 grams of flour and 50 grams of sugar for every egg used in this recipe. Figure 3 shows the first line of an algorithm that will be used to calculate the amount of flour and sugar required based on the number of eggs being used. So your eggs used equals user input. So we need to shade 1 lozenge to show which of the following lines of code correctly calculates the amount of flour needed in grams. So it's actually going to be C, flour needed is egg used times 100. It's not going to be eggs used times user input, that would be wrong. We need to input something for eggs used. There's eggs used, which is our input, times 100. Because that's 100 grams of flour that we need. Right, next one, shade 1 lozenge to show which programming language technique has been used in the lines of code on 3.01. That is going to be an assignment. Nice and simple. Okay, this one, the developer wants to use validation to ensure that the user can only enter a positive number of eggs, 1 egg or more. So the maximum number of eggs can be used in the recipe is 8. So we need to develop an algorithm using either pseudocode or a flowchart to show the number of eggs is validated to ensure the user is made to re-enter the number of eggs used until the valid number is entered. So that is 4 marks. So if I was to do this, I would do this. It would be repeat eggs used, user input. Okay? That's how I would do it, user input. And then what I'm going to do is I'm going to have until eggs used is greater than 0 and eggs used is less than or equal to 8. That is literally it there. But because you get 1 mark for the Boolean condition to check the lower bound of eggs used and the higher bound of eggs used. Using the correct relational operators. That's 2 marks. And then we got the assignment, obviously. So we got the upper and lower bounds. And we've got the iteration being a repeat until. We've got the user input. That's also another mark. We got the 2 Boolean conditions. Bosh, done. That's that. You don't need to say any more than that. Okay? There are other answers you could have, like do. You could also have do, eggs used, and then you can have while, and then you could change that to an or. That would get you 4 marks as well. But we're not going to worry about that. Let's just keep. It's a very simple algorithm. You're probably thinking, 4 marks for that? Yes. Yes, it is. Right, on to the next one. Some of my students who've gone through this actually struggle greatly with trace tables. So we're going to go through it bit by bit. Without the nonsense analogies of recipes, without the, oh, look at how good my soy sauce is. Oh, in my office stinking of ketchups everywhere. But hey, so we need to complete the trace table for the algorithm. In figure 4, for when the user enters a value 750 when prompted. So it means user input. So we got this figure 4. So we need to do our trace table. So we know the total size is going to be 300. So we have a look. Constant payload size 250. Header size is 50. User input, so 750. Total size of payload plus that. Number of packets is 0. Then we're repeating. Data to be sent minus the total size. So we are taking away 300 from the data to be sent, which is going to give us 450. Which is going to give us 450, just like that. And then in the number of packets, that is the iteration. So in the first one, we're going to have 0. And then after the 450, we're just going to have 1. Okay? And then it's going to be the same. So 450 take away 300 is 150. and then that's going to be 2. Last one is going to have 3 packets, so which means 150 take away 300, that is going to give us a negative. So once it hits data to be sent less than or equal to 0, that is when the program is going to stop. Okay, so that will get you 4 marks. So we've got 750 take away 300, 450, that take away 300, 150, that take away 300, minus 150. Bosh, done. If you can't do basic maths like that at this stage, there's something completely wrong with you. Or not something wrong with you, it might be something wrong with the teacher who just goes on about analogies of recipes. Or some of you might be spending too much time on your FIFA or your Fortnite and all that gibberish. Okay, next one. We need to state why both payload size and header size from the algorithm in figure 4 did not need to be included in the trace table, because they're both constants. And a constant, you don't change the constants when the program's running. Okay, for part 3, shade 1 lozenge to show which of the following best represents the input and output to and from the algorithm in figure 4. So the answer is going to be data to be sent as our input and outputting the number of packets. So if we go back up, number of packets is the output, whereas data to be sent is the input. There we go. Number 4. Developer wants to looks at that algorithm and realizes, ooh, we don't need iteration. We can just use div and mod operators. Div calculates integer division, mod calculates the modulus. So mod calculates the remainder after integer division. So the program realizes they can rewrite the algorithm, replacing the repeat until structure with the code that uses selection, mod, and div instead. So in this one, we've got to fill in the blanks. So as we're going to fill in the blanks, it's going to be data to be sent, total size, and number of packets. So you got if data is to be sent, modulus of total size, and that number of packets is going to be number of packets plus 1, because that's incrementing now. Yes, you may have to do, if you're doing this in C#, it's going to be ++. They'll accept ++, but I would just do +1 just to be on the safe side. Bosh, done. Okay, we are on the question, they got to ask! Yes, they got to ask it. Which is why, when I do tutoring with my students, this is one of the first topics, as well as the mathematical stuff, is what I tend to go over, because it's a question they've got to ask. Get the procedural mastery, you're laughing your way in and out of the exam hall. Okay? If the invigilator allows it, actually. Wink, wink. I know, because I was one. A few times. Okay. Back to this. The expression B and not A, or B and C, can be represented in a logic circuit in figure 5. So in the circuit, the logic gates are marked with labels instead of their proper symbols. So we need to state the name of the logic gate used in figure 5. So gate 1, that is going to be a NOT gate, because there's only one input and one output. That's a NOT gate. Gate 2, that's going to be an AND. Gate 3, that's also going to be an AND gate. Whereas gate 4, that is going to be an OR gate. Okay? But in this one, they want you to actually draw the logic circuit. Yep, so this is an OR gate for gate 3 or gate 4. Oh, okay. Logic is for gate 3. That's not going to be it. So it's just going to be that is an AND gate. You've got your two outputs. Yes, excuse my bad drawing, but I'm trying to draw on a computer, which I don't normally do. I prefer drawing in pencil, but use what you got. So if you draw out that AND gate for number 3, that's fine. For gate 4, that is going to be an OR gate. Yep, so it's going to be that, two outputs, or two inputs, one output. So that is our logic gate. Okay? Okay, why did I do that? Yep, so these are our two gates. If you draw them out like that properly, that's 1 mark in the back. So already we've got 4 marks. Okay, now we need to complete the truth table. That shows. So, AND gate, 0, 0, 0, 1. Okay? Okay, so that is that for the X and Y. Not X is just going to be 1, 1, and 0, 0. So when you're doing nots, it's the opposite of the input. And now we got to the more difficult one. X and Y or not X. So you got 0, 0, 0, 1. That's going to be a 1. 0, 1, 0, 1. That's going to be a 1. 1, 0, 0, 0, 0. That's going to be a 0. As it's not X. 1, 1, 1, 1, 0. That's going to be a 1. And that is our truth table. 7 marks in the back, if you get this right. Next one, truth table for complex Boolean expression, which is this. It's in figure 6. So we're going to show you one lozenge, which shows a similar expression with the equivalent of the original, more complex. So it's going to be A1 and A3. Okay? It's not going to be any of the others. It's not going to be a not, because you've got because there's more than one input. It's not going to be A2 or A3. If they're all 1s, it's a 1. The rest of them are going to be 0s. It's going to be A1 and A3. Okay? It's 8 marks in the bag if you get that bit right. Now, run length encoding. It's a form of compression that creates frequency data pairs to describe the original data. So you've got all of this binary bit pattern. That could be 6031141. There's 6 zeros followed by 3 1s, 1 0, and 4 1s. So the algorithm in figure 7 is designed to output the run length encoding for each bit pattern that has been entered by the user. So you've got L1, L2, L3, L4, L5. So we're going to show you one lozenge that should show what should be written for L1 at the algorithm. So then that should be user input. That's our first one. Second one, L2, that should be a 0. Then lozenge, and then for L3, we just need for L3, we're going to show you one lozenge to show what operator. There is going to be an equals. And then we shade one lozenge of what code should be written in L4. It's going to be the output count, because we're outputting how many times something takes place. And number 5, that's going to be I is equal to I plus 1, which is increment. Okay, so now we need to state the run length encoding for the series of characters T, T, J, J, E, E, S, S. So it's going to be 2T, 2J, 3E, 2S. Because you've got 2 T's, 2 J's, 3 E's, 2 S's. That will get you 2 marks right in a bag. Okay, a developer implements the algorithm in figure 7 and tests their code to check it's working correctly. Developer tests it only with the input bit pattern that consists of 6 zeros and correctly outputs 6 and 0. So using that test data, we have to state 3 further tests the developer could use to improve the testing of their code. We could test it with only ones. It could be tested with different lengths of input or different input lengths. Or we could also say it could be tested with an empty string. These are the ones that I would say. But you could also have, it could be tested with an input where the ones and zeros vary. It could be tested with an input where the last 2 numbers are different. It could be tested with an empty string, tested with a string of length 1, tested with 2 runs of zeros separated by a run of ones, or tested with invalid data. Doesn't matter which one you have, but if you mention 3 of those, you will get 3 full marks there. Okay? On to question 7! So, developer creates the algorithm in figure 8, which is below, to provide support for users of a new brand of computer monitor. So, we need to shade one lozenge to show which programming technique is used in line 3. That is selection. That is a selection programming construct. So you shade by selection, bosh, done. And then the next part, we need to shade one lozenge to show the data type variable ands in the algorithm. So we go back up, find ands, that's a string. And 703, regardless of what the user inputs, the same number at the output instructions will always execute in the algorithm. So how many output instructions will execute whenever the algorithm is run? 3. So 3 will be executed. Okay, so the phrase contact supplier appears twice in the algorithm. State 2 possible sequences of user input and contact supplier being output. So you could do no followed by a yes, and then a yes followed by a yes. Okay, so those are the 2 user inputs. Okay, next question. Another developer looks at the algorithm and makes the following statement. At the moment, the user enters Y or N. They'll sometimes get unexpected results. This problem could have been avoided. So explain why this problem has occurred and describe what would happen if the user entered the Y or N instead of yes or no. So you may wish to include references to the line numbers in the algorithm where appropriate, but you don't need to do additional code. So my reason would be the output message is not descriptive enough. So that would be, I would say, not descriptive enough. And I would say then I would also say the Boolean expression only matches exact values. So that would get me 2 marks. Then I would also say what would happen if they enter y at, say, line 5 or line 13, an incorrect message will be output. So in a question like that, they've divided into two sections. So you get 2 marks for each section. If I mention all 3 here or all 3 here, I'm not going to get 3 marks. I could do 2 here and 1 here, or 2 from here and 1 from here, from the reason bit. Okay? So we have to mention all of it, not just one part. Okay? Right. Next bit. Now we need to state the comparisons that would be made if the binary search algorithm was used to search the value 30 in the following array. So what it's going to do is going to compare 30 with 21, which is in position 3, and then it's going to compare 30 with 31, and then it's going to compare 30 and 27. So we know with 30, so we know 30 is higher than 21, so it's going to move to another position. Is 30, which one's higher, 30 or 31? Right, 30 is lower, so that stays. All right, let's check with 27. 30 is higher, so it stays. So the way they do it is compare 30 with 21, compare 30 with 31, then compare 30 with 27. That's it. And for a binary search algorithm to work correctly on the array of integers, what property must be true about the array? It has to be ordered. 9. We've got black and white image represented in a 2-dimensional array value where 0 is a white pixel, 1 is a black pixel. So you've got 2 images of inverses of each other if every white pixel in the first image is black in the second image, every white pixel in the first image is white in the second image. So a developer has started to create an algorithm that compares two 3x3 black and white images to see if the exact inverse of each other. So we've got to complete this algorithm. So ensuring that when the algorithm ends, the value of the variable inverse is true. So if the 2 images are inverses of each other, or false if they're not inverses of each other. So it should work for any 3x3 black and white images stored in image 1 and image 2. So we got our arrays. The Boolean expression inverse is true. And then we started in the while loop. So that is a 6 marker. So while. So in that one is where we are going to need some ifs. So in that we would have if image, getting those 2 arrays as image to those arrays, and then what it's going to do, it is going to, the inverse is going to be set to false, and then after that we can just end the if statement. We can just end the if statement just like that. And then we're going to increment j by 1. And then after that, we're going to end that while loop. We're going to increment I, and then we're going to end the while, thereby coming out of that loop. So that doesn't look like very much coding, but that will get you 6 marks if you get it right. Okay? So that's literally it. Okay, another one. Big long one. Developer wants to simulate a simple version of a game of battleships. Ships are located in a 1-dimensional array. There are always 3 ships on the board. a carrier, a cruiser, a destroyer. The board has 15 squares. Possible starting configuration, shown in figure 9, indicates where the indices are written above on the board. So the carrier, for example, is found at locations board 1, board 2, board 3. Player will make a guess to see if the ship is there, or part of it is there. It's located at a particular location. If a ship is found at the location, then the player has hit the ship at that location. Every value in the board is 0, 1, or 2. 0 is empty. 1 is if the ship at this location, and this location's not been hit. The value 2 is basically saying, yeah, it's been hit. So the developer identifies one of the sub-problems and creates a subroutine shown in figure 10. So what we have to do now, in that subroutine, that you've got the values true or false. Each element in the array board has a value 0, 1, or 2. So we've got to state the most appropriate data type. True or false, that's a boolean. 0, 1, or 2, that is an integer. Okay? They will accept int and they'll accept bool, but I would just say boolean and then I would say integer. Okay, next question. Developers taken the overall problem of the game battleships and has broken it down to smaller subprograms. So we've got to state the technique that the developer has used, and that technique is decomposition. Right, the identifier of the subroutine figure 10 is F. This is not a good choice, so we need to state the better identifier for the subroutine and why you chose it. So the identifier we could have, so that could be, so we could have not hit as one example. And the reason why we could have not hit is because, so explaining the C, so we could say that the purpose of the subroutine is to see if a hit has been made at a specified location. Okay, so that is what I would do. So 1 mark for saying a subroutine identifier, and another one to explain why we would use that identifier. Okay? Okay. The variable h in the subroutine in figure 10 is local to the subroutine. State 2 properties that only apply to local variables. So a local variable only exists while the subroutine block is executing, and it's only accessible within the scope of the subroutine. That would get you 2 marks. Last but not least, number 5. So we've got to develop a subroutine that works out how far away the game is from ending. So we should have a sensible identifier, take the board as a parameter, work out the output and how many hits have been made, work out how many locations containing a ship have yet to be hit, and if it's a 0, say it's a winner, 1, 2, or 3, say you're almost there. So that is going to be a big one. So we could have in here subroutine, how far away from ending, and then parsing the board as a parameter. Then you could have hits, 0, yet to be hit, 0. Then 4x, 0 to 14. If board, then we need to parse x is equal to 2, and then we need to have hits is equal to hits plus 1, because we need to increment the hits. Else, we need to have if board x equals x. So we got board, we're passing x into that, and if that's equal to 1, then what we're going to do is we're going to say yet to be hit. So we're using the yet to be hit variable, and that's going to equal to yet to be hit plus 1. So we need to increment that. And then we can do end if, because we're coming out of that if statement. And then we are going to come out of this if statement, and we are going to end the for loop. So we need to output the hits, and then go if yet to be hit is 0, then we go into another if, and then we go into output winner. Else if yet to be hit is less than 4, then we're going to say output almost there. Then we're going to end if and end subroutine. So an answer like that, that's almost guaranteed. That is 11 marks. That is one complete answer. That will get you 11 marks. So mark A. So that's 1 mark for creating the subroutine. For B, for passing the board as a parameter, that would get you 2 marks. Mark C, we're using the for loop, all over 15 locations on the board. That's another mark. Then we got the for E. Then we got indices to identify the value of each cell. That's another mark. And then we're using selection to ascertain whether it's been hit. That will get you another mark. Then we increment the value, the variable that stores how many hits have been made. That will get us another mark. Then for ascertaining the number of cells yet to be hit, possibly by using subroutine F, that will get you another mark. Suitable variable initialization, that's 1 mark. So you initialize the 2 variables, hits and yet to be hit. And then we get mark I and J just for outputting winner and almost there. And then output the mark F variable. That will get you your 11th mark. And that, ladies and gentlemen, is the whole question there. But let's see if there's any more, which no, there is not. That's all the questions. And there you have it, ladies and gentlemen. A comprehensive walkthrough of the GCSE Computer Science Paper 1 for the AQA exam board. Remember, practice makes perfect. So, calls to action. Grab some past papers you must. Give it a go you must. If helpful you found this video, don't forget to hit that like and subscribe button and share it with your fellow students. Subscribe for more content like this. Share the content far and wide. And as always, good luck. So please be sure to hit that like. And please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which made me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you were in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a Replit link below on my programming videos. So you just click on REPL, and this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click login, and once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page, so this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specialising in ICT and computer science. And I look forward to you coming to me for lessons. Goodbye for now.